This meeting is being recorded. Okay, good morning to all. First of all, I would like to thank each one of you for joining the second day of our 3 days workshop on data science and art for future. Again, I feel proud to say that this workshop has been organized by the Department of Computer Science and Engineering and Information Technology with Institutions Innovation Council of Bengal Institute of Technology, Kolkata, in collaboration with On Institute and Open Power Systems. Now, on behalf of Bengal Institute of Technology, Kolkata, I bid a very warm welcome to our today's guest speaker in the first talk, Professor Dr. Amartya Hatua, who took out his valuable time and joined us today to be a part of this workshop. We are happy to have you, sir. We are very privileged.
Thank you. It's my
pleasure. Well, we are also honored to have you with us, sir. I also would like to offer my regards to all the eminent delegates and the other peoples joined today. I guarantee that this workshop will be productive and worthly or precious time. Now, without any further delay, I also welcome Dr. Das and Dr. Arubusum Das. We have your sessions from 10 a.m. today. Welcome you, sir, once again. We have really enjoyed yesterday's session and we will be waiting to hear you again. Now, without any further delay, I would like to request Professor Moutan Mukhopadhyay Madam to continue the sessions from this point. Over to you, Moutan Madam.
Thank you, Tanmay, sir. I would like to welcome our guest speaker, Dr. Amartya Hatua and Dr. Argho Kusum Das, and all the dignitaries and all the participants on behalf of Bengal Institute of Technology. Now, I would like to request Orpita Madam to felicitate our guest speaker, Dr. Amartya Hatua, with virtual memento and flower bouquet.
Thank you.
Dr. Hatua worked as a postdoctoral fellow at the University of Houston after completing his PhD in computational science at the University of Southern Mississippi. Currently, he is working as a senior data scientist at Fidelity Investment. His work focused on developing financial prediction models for existing and prospective clients. In today's session, Dr. Amartya Hatua is going to discuss the most important mathematical tools such as discrete mathematics, calculus, linear algebra, and probability, and see how they arise in data science. Without wasting much more time, I would like to welcome Dr. Hatua to start today's session. And before starting of the session, I would like to request all the participants to be on mute throughout the session, and you can ask questions after this session.
Thank you. Thank you. Thank you, Professor. Thank you, everyone from BIT. I'm really happy and feeling very privileged today. So I'm going to start. I'm going to share my screen. Can you see this?
Yes, sir.
Yes, sir. Yes.
Okay. Good. So, as Professor suggested, that I'm going to talk about the important mathematical tools which we use in our day-to-day data science job. I'm going to talk about that initially, and I'm just not going to talk about mathematics because I'm not a pure mathematician. So I would give examples. Rather, I would say test cases where we use those. And towards the end, I would share something really interesting, which is again open source project I'm part of, and I like you can play with some web tool of the project, but that will come towards the end of the session. So this is a Venn diagram. I think many of you have seen, and those who are new to data science, they are going to see this very often. Um,
Amarto, sorry. Hey,
yeah,
Amarto, sorry for interrupting. Can you go
yeah.
to the presentation mode, because we are still in the first slide, important mathematical
Oh,
tools. You are sharing the PowerPoint. So,
presentation mode. Yeah, I'm.
Sir, can you please press F5? Means that will be fine.
Yeah, yeah. It is
yeah,
on presentation
you are
mode.
actually sharing the actual PowerPoint slide, not the screen. That's why
I
we
see.
cannot see it.
Okay, okay.
Just share the screen if it is possible. Then,
Okay.
otherwise, just operate in here.
Entire screen. Let's,
Yeah, I think that will be fine. Yes.
is it fine?
Yeah. That looks fine. That looks fine, sir.
Okay, good. So as the diagram suggests, that the data science has so many so many small parts come together, and the data science and software development and all those things have developed. But the fundamental three most important things are computer science and domain knowledge are the two pillars, and the basement is mathematics and statistics. So in a day-to-day life of data science, we use lot of computer science to create the pipeline and productionizing a data science model. And we use domain knowledge for a proper direction, such as I work for financial direction, financial domain. So I use a lot of financial domain experts input to develop my model. And with all those inputs, I use mathematics and statistics to develop my model. So maths and stats are the base of the entire domain of data science. I'm going to talk about two very important or very primary primary applications, such as regression and classification. Again, I'm going to talk about very simple regression and classification, but I would rather focus on the mathematical details which we use there. Okay, so this is a data science pipeline which we use in our daily work. So we get raw data. For my case, I get financial data. Some Before that, I used to work for some university where I used to use a lot of text data. So financial data is basically only the numbers. Text data would be numbers, characters, and so many other things. So most of the time, the initial data would be uh, some important thing and a lot of garbage. So the first job we had here is extract features, then create develop the model, and this block, the fourth block, the model tuning, that that comes with a lot of software life cycle approach. And if you know iterative models and all, so we develop some model, we check whether that is close to our desire or not. If not, we go back to our whiteboard, and we tune the parameters and come back to model and check the performance and so on. Once all the stakeholders are satisfied, then we go for deployment, and it's open for everyone. So the important part is developing a model and fine tuning, and the fine tuning, the parameters, all those things can be at their best if we understand the model, if we understand the underlying mathematical details of the model. So this is again something very popular example, predicting the price of a house. So here we are trying to predict a price of a house based on few features, say area, bedrooms, bathroom, and so many other things. So here is the data where we are trying to predict the y, and we have a lot of x's, and we are trying to make it as a linear structure. Linear is linear equation. Okay, so y is the prediction here, yi is the prediction, and all the x and betas are the x's are given. Most of the time x's are given, and we are trying to find the betas. Now betas are basically coefficients, and if you think in a if you want to visualize the thing, you can see here the blue color dots are basically the points, data points, which are say x's. So these are, you can think about single dimension here, or like x just this value and y is this one. Okay, so all the x, just think about x1. So these are all x1, and respective y1s are y1s can be calculated on the y-axis. Now this is given. This is given. Say right now these are the price of any house in Kolkata. So our job is, if a new combination of x comes, like new area, bathroom, bedroom, a new combination total. So what would be the price of that new house? So according to this formula, it would be somewhere here or here, and the price can be calculated using dropping a line from this point to the y-axis, and we can calculate the price. Now here important thing is how to get the new price. We have some data which we call in terms of machine learning language, we call it training data. We have some pattern, we have some history, you can say. We have history and we have to predict the future. So we have the history here, and we are predicting a line, or we are generating a line, and we would say if the line, we would say the line will determine the next price. So if my next x is here and my y will be here, that's all. So now going back to our +2 level mathematics, if I want to generate a line, or if I want to draw a line, what do we need? We need two things, C and M, or two constants. Here you can see, say beta 0 is one constant and beta 1 is another constant. So we have a family of equation here. So basically these are all, we can think about these all are equations, these all are y's, and this respective x's. Initially you can think about just one x, maybe one dimension. You can increase it to n number of x. That depends on your problem statement. Okay, so here we have a lot of y's here, and we can create now here comes your matrix multiplication and matrix operation. So in undergrad you must have studied matrix, and so this y's are creating one metric, that is the given. Okay, and this is another, metric. This can be divided into this two metric, and we can solve. We are looking for beta 0 and beta 1. We can solve beta 0 and beta 1, and we can create a line like this. Okay, so this solves the problem at the very first level. As I told you in the earlier slide, this one, we create the model, then we fine tune it many times till we are getting our desired result. So what we get here, we get some beta and we can predict some y, but is that very close to our desired result? Perhaps no. Most of the time, at the very first try, we won't get the desired result. So what we'll do, we will do it multiple times. So here we are predicting something, and here we have some result already. So we are comparing. So suppose we have this one. We are not using this for training. We are using this for testing, and we are checking how close it is. We found there is a loss, say some random number, and in the next time we are trying to minimize the loss. I will come to that point, how we are minimizing, but we will try to minimize the loss. So how this loss will be minimized? Think about this line, and we are adjusting the line in such a way that the error is minimizing, or the loss is minimizing there. Okay, so
Omar, sorry for interrupting once again. Your
yeah.
screen share just stopped actually.
Okay. Okay. Good. Can you see the screen?
Yes.
Okay, cool. Okay, so here we are trying to minimizing the loss. Now, how we will minimize the loss? That's a big thing, because if we can't minimize the loss, we cannot reach to our desired goal, right? So minimizing, or in other words, optimizing. So optimization is another tool. So first we are using matrix multiplication, and other solving multiple equation or family of equation. There are ways we are using that kind of mathematical tool. Next to that is optimization. Optimization, again, it's a huge area, huge area. Like a person can devote entire life just to read optimization. There's a huge area of mathematics. So here what we are seeing is called gradient descent. So what this is the curve, or you can think about, this is the function or the loss. This is the function, and we are trying to come here, right? This is the loss function here. In this case, the loss function is this uh, difference and the square of that. And what we are trying, suppose we are here and we want to come at this point. So if we want to go down, we have to do some differentiation, and we have to find what is the minimum, and slowly we'll go down, and somewhere we will find that this gap, this loss, is the minimum. And so how do we find minimum? If we go there and if we change something, it would be increasing again. I mean, if you follow the curve, if we come here and if you change something, it would be increasing, right? This side also, it's a higher loss. This side also higher loss. This is the minimum loss. So our goal is to reach at this point. What does it mean? This reaching at this point means we want to find some specific beta 0 and beta 1 value, for which this function exists, and we want to find that beta 0 and beta 1. Once we get that beta 0 and beta 1, we can draw this line, and that would be our prediction or regression in this case. So and that would be our best regression. So we can predict the number best, or the price of a house best on that number line. Okay. So for regression, we need, this is a very basic type of regression, but still we used matrix multiplication here, then solution of family of equation, then gradient descent, which is extremely important and very powerful tool to get our desired straight line in this case, or you can say the regression line. Okay, so this is one of the important branch of data science algorithms which we use. So in if you see deep down, that we are trying to predict a number, continuous number. So this line is a continuous number line, and we are trying to predict a number. So whenever we are try to predict a number, say what could be the example, tomorrow's weather forecast, or temperature, any continuous number prediction, we normally use regression. And that regression could be in much complex form, but the basic idea is the same. Okay, where it would be complex, it would be complex in this equations. This could be polynomial equation with multiple other things. Then we'll use different tools. Maybe we will use a more sophisticated tool, but the process will be the same. Okay, so from regression we would move to classification. Classification is another set of algorithms which gives us to classify of data. So what does it mean actually? If I say we all use Twitter, and sometimes we like, sometimes we don't like. Say in Amazon, we are writing our reviews. Some of them are good, some of them are bad. So the job of Amazon is, or the product owner is, to identify what are the majority, what majority is writing about the product, or some film review, or what the audience or critics are writing about the film. So we normally read them, right? But if it's a massive number of tweets, or it's a huge article, and every day normally in financial market we check regular updates, we check regular reviews, and those are very serious reviews, not just a tweet. Those are very serious reviews, and we need some automated pipeline for that. We can't read every line, and we can't decide upon that. That's a huge time consuming process. So we use classifiers. Here is this class, this what you are seeing here is called logistic regression. This is a logit function which is basically classifying or which is separating two classes. Some say a value of a function is 0.5 and above, say class 1, and 0.5 and below, less than 0.5, say is class 0. So you can think about a practical example. Say a tweet is positive or negative. If positive, then the value would be coming like 0.6, 0.7, anything greater than 0.5 or equal to 0.5. And if it is less than 0.5, then it's the tweet is saying something negative. Now, how does it work? Okay, if you are not familiar with this, no need to no need to be scared. These are just different form of error function, like this one here for logistic regression. Similarly here for sorry, the linear regression, logistic regression has its own function. uh, this is not very difficult, because if you think about this part, if y is 1, this part is 1 and the rest is 0. And if y is 0, this part is 0 and rest is working. So it's like if y is 1, this value will be coming, and if y is 0, this value will be coming, something like that. And together the function is written in this way, so it's little scary, but it's not very difficult. And oh, sorry. So what we are doing here, that's important. So similar to the earlier example, we are trying to find some loss here, and we are trying to minimize the loss here. So again, the loss is different, and the type of function we are using is different, but the method, that is first calculate the loss, then minimize it, is the same, right? And we are updating here. We are theta and alpha. I will come to alpha later. It's a constant, but we are here in the earlier case we have seen that betas. Here it's theta. That's just a variable name, nothing else. So what is alpha? That's also very important here. I'm going to talk about that. Before that, this is another way to describe gradient descent, or they call it downhill function. So we are here somewhere in the earlier curve we have seen, and it is coming down somewhere here. And once I get this, this is a 3D, right? So I can have x and y, and the function value of x and y is also here. So it's like in this example, j theta, say this is j theta and this is theta 1 and theta 2, and we are getting j theta value here. Now I'm coming to the value of alpha. What is new about alpha is, if I choose alpha, a very high value, it would go like this, then this. So it's basically helps to reach our optimization point fast. But the problem may happen like here, we may overshoot the optimization point and we go beyond this. So we'll reach here at the down. Maybe the next step will be somewhere here. So our desire is to reach at this point, but we will never reach that point because the alpha or the steps is very high. While in contrary, if we set is very low, it will reach, but it would take a lot of time, like say 1 day. If it's a very big problem, it may take 1 day. So we have, while we are using our functions, while we are setting our values, we have to be very sure, or we have to go through multiple steps to identify a proper value of alpha. Now again, that's the point. How would you predict a value of alpha? If you know the function well, if you know the data well, then only you can have a good estimation for alpha. Otherwise, maybe you would eventually reach the point, but it would take a lot of time. So to be efficient, you have to know these functions and their behaviors. Similarly, there is another thing called normalization. So in data science, normalization is something like when we get the data, we first do cleaning, then do normalization. Why we do normalization? Suppose the initial data looks like this, and we have to reach from this point to this point. So these are just different ways to visualization. So that you can get all the different graphs. These are very common. Okay, so this is basically the same graph from you can think about, you have sliced it and you are seeing from one side. Okay, so you have to go from this point to this point, and this is not normalized, so it takes a lot of time, because somewhere up, somewhere down, and so on. But if the data is normalized, say it is normalized between 0 and 1, or min and max, so it will look like this, and you can reach from the initial point to the optimized point very fast. So as a data scientist, your primary job is to find the correct model, and that's not enough actually. So you have to develop your model in such a way that would give you good result, and it should give you faster result as well. Normalization also helps us in a lot of other ways, like suppose you have developed your model with certain set of data, and you got a new set of data which is not and before that you are not normalized your initial set of data, and if you get a new set of data which is in the outliers, so your model will not behave according to the way you want. Okay, so this is classification, and one of the example of classification is sentiment analysis, or the positive and negative tweets or text or article, whatever you can think. So in the tweets or in the article, we will get something like this, the text, right? We cannot use text as our input for our machine learning models, or any kind of algorithm. We have to convert it to numbers. Now there are different type of process. There are different methods you can convert from text to numbers. Say there are bag of words. Bag of words means there are keywords, and you can find that, suppose happy, joy, something, some words, happy words are in one set, and sad words in another set, and you have certain rules that if you have more happy words in a text, then that is a positive text. But what about sarcasm? What about someone quoting someone? Okay, so there are a lot of nuances over there, and we have seen the bag of word models are good for in a limited scope, not in a very big article or very big text. Okay, so the most popular model is word vector model, or word vector embedding. What is that? That is basically they are treating every word as a vector. Okay, so you can see here cat, dog, and a lot of other words examples are here. And so here they're treating every word as a vector. Now this vector is not just like two-dimensional or three-dimensional vector. No, here it's just a toy example, but the vector can be 1024 dimension or 256 dimension and much more. And they're creating a big vector space. Now vector space is another thing, vector algebra you have studied in your undergrad. So they're using the vector algebra to create the vector space. And the vector space is very interesting. As you see here, man and woman, the difference of so this one, king minus man, is almost equal to queen minus woman. And the distance, you can see the distance between the country and their capital are almost same in every case. So what that suggests, if we think about word cloud, most of the words which are similar are uh, come come together, like say flowers, all the countries, all the rivers are very closely located in the word vector space. And how and what does that help? It is helping, like suppose you want to develop an app which will suggest the best dishes, the recipes, and you can find the words very close. So say fish. Uh, Fish is very closely located to chicken or egg or something like that. Whereas some flowers, all the flower names are very closely located. So you can think about like whether rose is similar to lotus or rose is similar to egg, and you can calculate the distance based on the vector, and you can find that rose is similar to lotus. Now these are very trivial examples, I know, but in a bigger perspective, if you think about you have a 200-page document and you want to check whether that 200-page document is similar to another 200-page document, and you will find this is the most effective way to find that similarity. Okay, so this is basically the word embedding, and we use this word embedding, these numbers. So suppose we have to find the sentiment analysis. So the earlier slide, so this text can be embedded using this word vector method, and we can get a huge metric like this, and then we will go back to our classification method and we will find which is positive and which is negative, or which is good or bad or whatever. We are talking about just two classes. We can do it for multiple classes. Say point, we can divide it like from 0 to 0.25, 0.25 to 0.5, and so on. So this is another very important tool. And the final thing which I want to show you, which is open source project I'm part of with SETI organization, NASA. And what they are doing, they are using machine learning tools and pipelines to find the meteors at night. So they have cameras across the globe, and they are collecting data, and they have, these are the data, and the model is running there. What they are trying to find, at night we can find a lot of moving lights. Okay, some of them are flights, some of them are maybe some other planet. They are looking for only meteors, and from meteors, if they find a new meteor, they can find perhaps they can find a new star maybe. And how the process is going, I will tell you. So okay, so they are capturing these 5 important parameters. So the cameras are not actual cameras. They are they are capturing these features. And this is basically data from 2 stations. You can see from station 1, and this is station 2. So suppose one meteor is visible from station 1 at this point, timestamp, say from somewhere in Amsterdam, and the next station is somewhere in London. So station 1 can see up to this, and then station 2 can see till the end. So you can see a meteor which is started here and ended here has a very uniform or gradual progression of colors, change of colors. I will tell what does it mean, the colors. But you can see it's a continuous thing, where which is not a meteor is that looks like this. It's a very discrete and suddenly it's starting, suddenly is going off, and it's the pattern is very clear. Now what the color suggests? The color suggests uh, they call it attention. Okay, this if you go a little high, deeper in this domain, you can study deep learning, and there is something called attention networks. So attentions are basically they remember what was in the past and what is in the future. Suppose we are translating a big text from, say, Bengali to English, and we have started with a female at the beginning, and towards the middle we are using a pronoun, and what we would write? We write C. Okay, so attention networks helps us to remember that. Similarly, here we are using attention network to remember the pattern from beginning to end. Okay, and this is something really interesting, and it's an open source project. So I would like to share some link in the chat. This is the link I would share the link in the chat, so that you can go and check the website. This is basically last night's so this is on December 7th. I have if you go to this website, you will find the last what happened yesterday, and these are the meteors. Okay, the whites are meteors and the blacks are basically stars. So we are using deep learning algorithms to identify the meteors, or again, this is the classification. The classification which I described, we are using exactly same process, but little sophisticated tools. That's all. Okay, so I can go to that link maybe like to show you. Yeah, it is working, but in my local system, you can I can show it better. Uh, these are the constellations. Some of them are visible, some of them are not. So I can share this link to you so that you can play with this. And that's all from my end. I would happy to be answer if you have any question.
Thank you very much, sir. The session was very wonderful, and you explain all the mathematical concept behind the regression and classification. You already explained very clearly the normalization concept, the error function. All the concept was very much clear, I guess, for all the participants. Thank you very much, sir.
Thank you.
Thank you, sir.
If anyone have any questions, you may raise your hand or directly write into the chat box.
Yeah, I have shared the link. If you have time, you can check. And for all the students, I would like to say that if you SETI organization provides internships, so if you want, you can apply. I think they are currently taking the applications, so go ahead and apply. It's a you can work with them from India. You don't need to travel. You don't need to worry about that. Okay.
Any questions from participants? And
I have one question also for you. So what type of analysis do you mostly use in your financial sector? Mostly, I mean, what type of mathematical tool do you use? Is it for the classification like logistic regression or linear regression or polynomial regression kind of things?
Very good question, Arvoda. So we use so financial market is very volatile. we use lot of different tools, and we consult our financial analysts, and then we take decisions. So we use tools such as time series, which is very much popular, and we used different tree-based regressions and LSTM sometimes for regression as well.
Okay. So mostly you do like the time series analysis for all your work, or there are
Most of the
several
time
other
time
important-
series, but what we have to do other than just regression, we have to explain why the result is coming that way, why we are suggesting that. So we use something like explainability tools, Shapley value. So we used say uh, one tree and one Shapley. That's a combination
Okay.
together.
Mhm. So yeah, that gives rise to another question actually. So
Yeah.
since you are talking about the explainability, now this deep neural network, currently it's the booming buzzword, right? So is it very much useful in the financial sector also? Because the fundamental controversy is like, well, deep neural networks are just giving the correct result,
Yeah.
but no, you cannot explain it
Yeah,
clearly.
yeah.
So
That's why
what do
I
you think?
said that's why I said tree-based models.
Okay. All right.
Tree-based models are visually, I mean, visually you can explain that. And financial sectors, it has been they are in the market for a long time, and they have their very stable system. So if you want to introduce something new, first of all, you have to be good at the result, and more on top of that, you have to tell them that you have to convince the higher authority management that this works better in that in very particular way. Now this is a conflict, you can say, or this is a problem rather. Not I won't say problem. Also, we use different different vocabularies. You can understand, or you if you are talking to an academician about a model, you can use some words and they can understand in that way. But when you are talking to some finance guy, that person may not understand the same word the same way, and that's the challenge.
Yeah, that's where the domain knowledge actually comes into picture.
Exactly,
And I think it's
that's why domain knowledge comes to the picture.
Mhm. And I think it's very important to understand that, well, sometimes I mean, in current situation, sometimes we start thinking like, well, deep neural network or deep learning is kind of a panacea for everything. Well, it's not. When
It's
you
not.
come to like this type of critical sectors, like this financial sector, or let's say healthcare sector,
Exactly.
where everyone where you need to explain all these things, there you
Exactly.
have to rely on this tree-based model where you can embed the prior understanding, prior human understanding in your knowledge, and also it gives you a little bit of explainability to the model, and also I believe it will help you to calculate the uncertainty too, right? Which
Right.
is very much very important.
Exactly. Even we have models, but we don't use mm, because if Facebook loses some client, it's just small, not even significant percentage of their revenue. If we lose some client, it's matter of $1 billion. So there is a huge difference of business strategies, and when to take the model, when not to take the model, and so many things.
Well, I have one question, Dr. Hatua.
Yeah, sure.
So with continuation with Dr. Orbo, as you are suggesting, that find that model is kind of a little bit dependencies are there. Means that actually suggests. Means it depends on a sector of data or sector of things you are getting, and depending on that you are building the tool. And that's why we are coming some generic way of tree-based tree model and all. But is it possible in later, means after maybe if it is some rules or some definitely there should be some generic rules should be there. If you can collect those the human understandings and all the data from the other sectors, and you can merge them all together, then probably that probability can increase later on, and that can
Right.
that can increase the
There are ways we use something called transfer learning.
transfer learning. Yes.
So
Yes.
there are ways, but again, when it's a critical sector, you are using the. I would say there is a very booming area of research is AI NLP or NLP AI something. Explainable AI with NLP. So your car, suppose you are in a automated self-driving car, and the car is stopped in a stop sign somewhere. That's not enough. The expectation is the car will tell why it stopped.
Right. It actually very much related, and lots of factors are also affecting.
Yes, lots of factors are involved there. Yes, it is. I can see a question.
Also, I believe there is a small question in the chat window.
Sir, is gradient descent useful if more than one local minima exists?
Good question. Yeah, it does. Now the thing is, if there is more than local minima, the problem of gradient descent is sometimes it stuck at the local minima and it cannot go to the global minima. So I hope the person who has Ujjal, you must be knowing the difference between local minima and global minima. And here, whatever example I have set is I consider it is a convex plane, and it is always has one minima. But if this is not a convex plane, there are ways to overcome this kind of problem.
Any questions?
I think Swastik done. I think you have some questions.
I
So
think
we can.
Srijoni Somar, someone has raised her hand some point.
Okay.
Yes,
If
but
I can
no, it's not showing in the.
So Srijoni, if you have any question, you can feel free to unmute yourself and you can talk, or you can write in the chat window also.
Okay, so please, anybody have any question, any queries, you can free to ask, sir.
Sure. All right. So Amartya, do you have any LinkedIn profile, or somehow the students can reach you out in case of any question related to this setting or whatever you have said there, or offering some kind of internship, or if anything?
Sure. I have LinkedIn profile.
Yes,
I can
sir,
share.
please, can you share in the chat box?
Maybe I can share my email ID and you can email me anytime. Here is my email ID. Just email me or connect. No problem. Or you can get my details through Dr. Das.
Sure.
Thank you, sir, for answering all our questions.
So thanks again. It's my privilege, and thank you.
Sir, we will be sharing a token of appreciation now. Shreyoshi madam, please share the appreciation certificate.
Maybe there is a technical problem.
Okay, madam, let me share the certificate.
Okay.
Thank
Or
you.
is it visible to you?
Yes.
Yes,
Thank
yes,
you.
yes.
Thank you very
Yeah,
much.
it's a very small token of appreciation
No,
from
no
the
problem.
CIT and from the College
Thank you. Thank you, Tanman sir.
Sir, we'll share these to you through the mail, right?
Sure.
Thank you.
Thank you.
Over to you, Muthan madam.
Okay, thank you, Tanman sir. In today's second session, Dr. Orgho Das will show us a sample curriculum for machine learning for developers and institute approach. So without further delay, I would like to request Dr. Das to start today's second session.
Sure. Thanks, Professor Mukhopadhyay, for giving me the opportunity to talk about our curriculum. But before going to our curriculum, let me thank Dr. Hatua for accepting my invitation from Institute's perspective, because this is a collaborative approach. And Dr. Hatua, thanks for joining this meeting and spending your valuable time for the betterment of the community for this collaborative effort. Thank you. So anyway, so without any further delay, I will be starting my presentation. So, well, before going to my presentation, once again, thanks a lot for joining this webinar. And once again, thanks a lot to BIT, the entire BIT family, especially the organizer of this webinar. Thank you. And thanks on the behalf of Institute for giving us the opportunity to collaborate with you. And my presentation will be kind of compensating what Dr. Hatua said. So Dr. Hatua has focused mostly on the mathematical tools, which is very important, which is the fundamental concept of machine learning, because whatever you are doing, everything in the data science domain, in the basement, it's all mathematics. So that's a wonderful introduction. And what I will do in order to be productive in the industry, what you need to do, what other skills you need to develop in order to be productive in a data science industry when you will work in a real world project, how to develop the developer's mindset rather than mathematics and all these things. So that will be kind of compensating, and that's the major motivation we kept these two talks one after another, so that the students and the faculty member, everyone can get a full landscape, everyone can understand the landscape of machine learning, where we are and where we are heading, and what are the major things that we need to learn or that we need to teach. So let me start my presentation. So let me share my screen, and so I hope you can all see my screen, right? Can you see my slides?
Yes, Dr. Das.
All right, perfect. Thank you, Tanmay, for confirming. All right, so once again, I am Orgho Kusum Das, and I am an assistant professor of computer science at University of Alaska Fairbanks, and I am an advisory board member of Institute's Data Education Initiative. So in today's presentation, what I will discuss about Institute's AI Education Initiative. Specifically, I will describe, like, if you are developing some kind of machine learning curriculum, what are the things that you should remember to include in a state-of-the-art machine learning curriculum. And that's what we are doing in Institute. We are teaching many students about machine learning, and as I told yesterday also, that those students are not only coming from the science, technology, engineering, or mathematics, that is STEM domain. They are coming from all the different domains. Some of them has liberal arts background, some of them has totally biology background. Everyone is using machine learning, and for all of them, it's not very easy to understand all the fundamental nitty-gritty details of the mathematics and everything. So how you can teach all of them based on their personalized needs. That's what we are going to develop. And I will give you the broad aspect of machine learning from a development perspective, how to be productive in an industrial situation. So here is the presentation title. Let's call it like machine learning for software developer. And well, this course we have developed in collaboration with Facebook. Well, I mean, today's talk actually was supposed to, I asked my Facebook collaborator to give this talk, but he has some personal problem. That's why he cannot come. That's why I'm doing it today. But anyway, so we have collaborated with multiple different industry to develop this type of state-of-the-art course, this machine learning for developer. And this course I have tested in Platteville, University of Wisconsin, Platteville, where I used to teach earlier before joining University of Alaska Fairbanks. And this course was very highly rated by the student. So everything is very much well tested in the domain of education. So here is the agenda. First, I will discuss about the current state of machine learning, where we are. Then we will discuss about the expected learning outcomes, a developer's perspective. And then I will discuss about the institute and its collaborative effort. I just discussed about all our company collaboration and how we are working. Then we will discuss about the course highlight. I will show a little bit of coding demo, just so that you can understand how to develop a developer's mindset. And finally, I will discuss our goals, where we are heading at Institute. So the current state of machine learning, as I have told, it's cross-disciplinary, and it's not only the STEM, but students are coming from everywhere, from the non-STEM domain also. And now the application of AI and ML is kind of everywhere now. Since the data is issued from many different experimental facilities, from your mobile phones, from everyday life, and all the other places, AI ML has spanned its tentacles to everywhere in industry, starting from e-commerce to social media to automated vehicle to targeted advertisement, personalized medicine, weather prediction. Every places you can see the application of machine learning. And since everyone is using machine learning, you cannot expect that all the students will come from with a strong mathematics background, or strong science background, or strong programming background. So how to teach them? I mean, what are the things that you should remember when designing a machine learning curriculum, and what we are doing in Institute? That's what I am going to tell now. So the point is, the existing machine learning curriculums that we follow, the traditional machine learning curriculum or AI curriculum, that needs to be better. It should be updated to fit the business needs, as I discussed, and it should be tuned for the software developers rather than just working with the theories and everything. You should focus on the productivity. Now, also, you have to consider the machine learning project management, because whenever it comes to industry, it's all about the software development. It's not just writing one single piece of code. You have to develop the curriculum for the project management perspective also. How a project manager will manage a machine learning project. It's tremendously different from the normal project and the machine learning project. They are different. And also it should be accessible by the people from different background, as I told earlier also. So here are some of the expected learning outcomes from a developer's perspective that we must remember. So the first thing is, of course, we need to remember ML is not only mathematics. There are lots of different things. Well, of course, the basement is always mathematics, but think in this way. At some point, programming was also about mathematics in the era of Fortran, or in the era of some Pascal language. It was all mathematics. If you don't know mathematics, then you cannot do programming. Then everything changed. C language was introduced, C++ came, Java came, and currently Python came. And now actually, you really do not need to know any type of mathematics to learn programming, right? It became significantly easier and significantly, it spanned to many different domains. So in case of machine learning, we are at that inflection point where machine learning is taking a different shape in the landscape of education or in the landscape of the application. So here basically machine learning, if you want to know machine learning, so you need to know mathematics a little bit, of course, but you should have the understanding of the data. That's what Dr. Hatua was saying. The domain, the language is totally different. So all these things are required. You have to understand the type of problem. What is the customer, what is something that customer wants? Sometimes customer does not know what they want actually from machine learning. They think that, well, as I was saying, they think that, well, the deep learning is panacea for everything, but it is not. So you have to understand customers' actual need. So those things actually need the different types of skill sets for machine learning: how to extract the requirement, how to do the feasibility analysis of the project, how to manage a project, how to develop some robust code so that you can easily change, and all these things. So those things are very much required actually. And here, when we are talking about the KPIs, means the key performance indicators for machine learning, as Dr. Hatua also told, that it's not only about the accuracy of the model, but there are several more, something more to it. For example, your machine learning model should be capable of analyzing large-scale data. It should be capable to extract more knowledge from less data. Of course, accuracy is one part, but at the same time, you have to improve the robustness also, how it can work with multiple different types of data. And also, of course, a performance is a big factor, like less execution time to train a model. As Dr. Hatua was saying, that, well, sometimes it takes 1 day. And well, I think this 1 day is kind of an understatement. Sometimes it takes a week also to learn a model. And we have faced those type of challenges when I was doing my PhD, and these TensorFlow or PyTorch and GPU-based computation was not there. So at that time, when we started working on machine learning, it was the inception point for modern machine learning, I should say. We have faced that type of challenge, and that actually, forced the industry, the current situation, to do something. How to make it productive, how to make productive tools to do machine learning related things. And of course, one more thing that as an industry expert we need to remember is performance to price. Well, you develop some kind of model which is very much accurate, but you have realized that, well, this model is cannot run without 256 gigabytes of memory, just to give you an example. Well, this is not acceptable model then. It does not have any real world application. So all these different things, especially the return on investment, performance to price, all these things you have to consider when you will learn machine learning, or when you will develop a machine learning model. And that's why it should be included. That's why it should, the entire understanding of the workflow of machine learning should be included in the curriculum. That is, you have to improve the productivity, for example, like use different libraries rather than developing from scratch, try out different models, try out different types of tools, how to develop like the CI/CD, continuous integration, continuous development pipeline. All these different things are being integrated in machine learning. So just as a the point in here, ML projects are not only about the theory. There should be a proper balance between theory and the development knowledge is extremely necessary. Now, Institute here, we have collaborated with multiple different companies like Facebook, Fractal, Fidelity, IBM to develop the course for machine learning for software developer. So now, here I would like to give our collaborative effort that what we are doing. So about Institute, I believe you got much idea of it, but just to say that at Institute, we focus mostly on the data education, or we can say like data education is one big data problem that we are committed to solve. And here are all our collaborative partner with whom we are collaborating to spread quality, high quality data education across the globe and want to make the data education accessible, affordable, and available to anyone, anywhere, at any point of time. So so that's what our collaborative effort. So now let me give you a little bit of course highlight, like what we are basically doing in here. So here our course is developed for the absolute beginners. So no matter what is your background, we teach you from the prerequisites. We do not expect that you will have a knowledge on linear algebra or you already know some coding or something like that. We have the courses, we have the materials ready to teach you from the prerequisites, from the absolute beginning to a pro level. And so our courses are for university students like aspiring to join machine learning industry, no matter what your background is. And or sometimes we teach the professionals also with the switching career to ML, who are basically switching, who used to work in a different domain, but switching the career to machine learning or data science. We target the project managers, team leads also, how to manage these machine learning projects, all these things. So we basically start with learning Python. We teach them different types of analytics or productive tools in programming like NumPy, Pandas, as well as we teach all these scikit-learn, PyTorch, TensorFlow, all these different types of tools based on their requirement, their personalized needs. That's what we are doing. So here basically the course highlight is you will be learning the code developed by the industry practitioner. With our collaboration, we have basically found out the fundamental pipeline of machine learning, and then we have developed several hand-grown codes which are specifically copyrighted to us, and then we are teaching using those type of codes to teach the students about machine learning. With those codes, we basically develop your developer's mindset, as well as we basically try to make you productive, basically, so that your fundamentals are clear, even if you are not from a STEM background or something. And so well, here our focus is always on the hands-on exercises on Jupyter style notebook or many other different machines, many other different tools are there. And you can also be involved in our projects tuned for your needs, whatever be your research area. That we will discuss possibly tomorrow. And so here we have like hands-on pre-configured VM virtual machines and containers, where you really do not need to worry too much about the installation and all these things, but just with some basic installation you can start learning and everything. And we also offer for selected customers, we also offer infrastructure also, hardware infrastructure, where you can get a chance to work on specific hardware, different types of high performance computing machines. And so here let me show you a little bit of coding demo. And yeah, so let me show you a little bit of coding demo. So here basically, so what we are basically doing is, let's say here, So Dr. Hatua has told different types of mathematical tools, and he talked about linear regression and classification, logistic regression, and all these things. So what we are trying to do here is, in order to clarify your concept, we have created kind of a we are developing our homegrown code so that utilizing all the different tools. So all the different machine learning models are developed using all the different types of tools, so that our student can learn the fundamental differences between all these different types of tools. For example, in this code, as you can see here, we have developed like logistic regression with scikit-learn. Here we have developed the same logistic regression things using TensorFlow, and here we have developed the same logistic regression with PyTorch. So with different types of tools. In this way, if you see the similar model have been developed in using different tools, you can easily understand what are the fundamental differences among all these different tools. Why should I use PyTorch? Where should I use TensorFlow? Or when should I use scikit-learn? All these questions will be clear, and your knowledge, your learning requirement will be satisfied. And also, as I was saying, like we have found the fundamental pipeline. So if you just look at the code, you will see that all the things, everything is kind of similar. It's not only about learning the model. There are lots of different things, like how to download the data, exploratory part of the data, scaling of the data, split the data into training and test sets, then training the model. So all these different, so Dr. Hatua was talking about normalization, right? So here, basically, we are doing different types of scaling, normalization and standardizing of data, all these things. And what you can see is these steps are basically common in all the different types of models. So here also, when we are developing the code with PyTorch, it has all these models like explore the data, download the data, explore the data, scale the data, split the data, train the model, all these things. And when we are working with TensorFlow, then also we have the same steps and the exact similar type of code. So the point is, and after that, so all these things are same, and then training part is a little bit different because we are using different library. The same is true for all these scikit-learn also. Every steps are same, and the training part is a little bit different. So the thing is, this way actually you can understand where the difference is coming, because in the internet you will get lots of codes, but they are full of noise. Sometimes you cannot understand what they are doing. Lots of different things are done which you really do not need to do for your purpose. But how can you better understand it? So that's why we have developed this code in this way. So that's a small demo. Well, it was not a demo, just I showed a little bit of code how we are doing, and this way you can develop your mental developer's mindset basically. So basically our goal is to create a model zoo, ONNX like model zoo for ML education, where basically we will have all the different models developed in all the different popular tools, so that you can understand the fundamental differences between all the models and all the tools from a developer's perspective. So in conclusion, we are open for collaboration always. As I told earlier also, if you want to adopt the course in the university, you can contact us. If you want to improve your courses, then also you can contact us. And if you want to do like organize this type of workshops, hackathon, or prepare some kind of guest lecture, then also you can contact us, and we will be happy to collaborate on all these things. And so that's all from this presentation. And yeah, and now I am open for question.
Thank you, Dr. Dash. The session was very much informative and very nicely conducted. And you explained all the applications of machine learning, and in your institute, institute, student will get a chance to apply their knowledge to implement their knowledge. So I think that will be beneficial for our student. They can go for any internship in your organization or any kind of training they can go for. So if any questions from the participants, then they can ask to Dr. Dash.
Sure. Since you talked about internship and students' participation, so we have a very good program. We collaborated with Open Power and Object Automation to offer this type of internship. So if anyone is interested, just feel free to contact me. We have those type of provision. Yes.
So if anyone have any questions, they can ask. I think
I got
okay.
one question here.
Which code you have used in logistics?
You mean logistic regression?
Yes.
So so here, can you please explain? I mean, which code? I mean, we have developed the logistic regression model utilizing scikit-learn, TensorFlow, as well as PyTorch. All these different tools. So that's what we are doing. If that answers your question. And we always focus on the Python programming language, mostly because that's the easiest way and that's the industry standard kind of right now.
Any other questions? So, sir, can you share your contact details in the chat box so that if anyone want to contact you, they can?
Sure. The best way to contact me in my LinkedIn address. So let me just copy paste my LinkedIn address over here.
Copied your LinkedIn profile.
Yes, I have copied my LinkedIn profile. The students, if you are interested to learn machine learning, if you are interested to take part in projects, if you have any other type of question, please feel free to be in touch with me.
Thank you once again for answering all our questions. And now it's time for, we will be sharing a token of appreciation now. Tanmay sir, could you please share the appreciation certificate? Is it visible, sir?
Yes, now it's fine. Extremely sorry for the inconvenience, Dr. Das. It's kind of like technical issues.
No, that's okay. It happens to me. You are not the first one who got this issue. It happened to me also. So don't worry.
So, very sorry, sir. Very, very sorry.
No problem. So I think Mr. Ganesan Narayanaswamy is already here, and thanks a lot for giving me this token of certification. I really value this. So I think Mr. Ganesan Narayanaswamy is here, the next speaker. So maybe we can move to the next speaker.
Yeah, sure. So before I start, hi, Dr. Ganeshan.
Hello, everyone. Good morning to all.
Yeah, good morning. Very good morning to Dr. Ganeshan Narayanaswamy. Very warm welcome to you, sir. And we are privileged that you took out some valuable time from your schedule and join us. And thanks very much. Thanks to you, sir. Over to you, Mota madam.
So, sir, now I would like to request Orpita madam to felicitate our guest, Mr. Ganeshan Narayanaswamy, with virtual memento and flower bouquet.
Oh, very nice. Thank you. That's a good idea.
Thank you, Orpita madam, for sharing this. Thank you, sir. So,
and one more thing, actually, like, my screen share is not enabled. So just want to tell you that.
Yeah, sure, we'll enable you.
Yeah,
can you please, Ganeshan said to be host. Seriously, madam. Yeah, ma'am.
Okay, sir. Okay, sir. I will.
In today's third session, Mr. Ganeshan Narayanaswamy will be the speaker. So he is a senior technical computing solution and client care manager at IBM. He is going to discuss about the institute and open power infrastructure. He is an IBM global leader for AI and cloud enablement and ecosystem for IBM open power system. Mr. Ganeshan is best known for his contribution to AI, cloud, and HPC as a senior leader for nearly 2.5 decades. Mr. Ganeshan is always passionate about working with universities, research institutes, and industries to provide all kinds of technical mentoring and motivational speech. So, sir, over to you, sir. Without further delay, we can start our next session. So I would like to.
Thank you.
Ganesan sir, please check whether your sharing option is enabled or not.
Yeah, it's enabled. I'm trying to share my
sure,
screen.
sure,
Thank you.
sure.
Thank you for the introduction.
Yeah,
The big
thanks, sir.
team, really appreciate it. So let me go over the things right now. I hope you all
Yeah, it's visible.
able to see my screen. Okay.
Sir, I think.
No, I'll do that.
Yeah, it's fine. Now it's fine.
Yeah,
Now it's
I know. No, I'm working on that. I know where you
no,
want me to.
it's okay, sir. Thank you.
Okay. So as Madam said, about my experience in IBM. Yeah, it is 25 years ago I joined IBM as a programmer in Poughkeepsie, New York, and I started my career with working on a computer called SP system. It's called Scalable Power Parallel System, SP2 Power Parallel. The P2. So with that system, I started doing lots of testing and all. Testing the back end, with the control station, and even Fortran kind of programming. I have actually done during those days. I hope you guys know about Fortran, but still the Fortran is heavily used by lots of scientists in United States as well as in Europe. So the SP2 systems, when you talk about, is basically the system which we built to play as a commercial part, to play a game with Gary Kasparov. During that point of time, he was the #1 chess champion in the world, Gary Kasparov, and IBM built a system to play against the Gary Kasparov, and we did win. 2 times we win, and Gary also won against one time with IBM system. So it was a great opportunity for a lot of people behind the scene working on that kind of environment. So anyway, just wanted to add a few things, like why I want to add here is actually because 25 years back I joined IBM, but IBM's 111th year this year, 111th year, only one company, a technology company, would have been having lots of technology rolling, is IBM. See here, I talked about SP2 system, and I'm going to talk about many things, what I have done and what I'm going to do in future also as part of this call. So it's a great opportunity for you guys to listen and basically get some good ideas how to use the infrastructure what we have put together worldwide, so that these are all very good kind of a seed for you to grow in your career as a center of excellence, or whatever you can do in that. So anyway, so this talk I'm going to be covering one by one on that, so we have the IBM Center of Excellence concept, where we set up Center of Excellence, and we basically provide a lot of technologies to universities, startups, ISVs, and also industries. That's very important. The all 4 things where we develop that ecosystem to help develop further the impact of today's world. Looking at artificial intelligence, even previous speaker and also my very good partner of the IBM Open Power, Mr. Agyadas, mentioned about the machine learning and various concepts, right? That it's all under the artificial intelligence for solutions for real world opportunities. There are just record my maybe say my word here. There are a lot of opportunities for next 5 to 10 years with AI, from chip to solution. Chip, you can even develop if there are any computer science and electronic students, they can develop using our infrastructure a chip also. We recently launched zero to chip development kind of program also as part of IBM. So one of the partner called Open Power Foundation. With that, we announced some kind of workshops worldwide. So there are a lot of things one can do with our technology even today. I'm going to walk you through what are the things one can do, and there are a lot of freely available things that are available where you can get some skills immediately starting from today also. And our key technology partners, I would say, the IBM Watson, Red Hat, Power 10, Power 9, Samsung, NVIDIA, Ubuntu, Open Power, Object Automation is one of the partners in India. That's why I mentioned here. But there are other technology partners who are actually independently, contributing to this ecosystem that I am going to mention in the following slides in a separate area. So why these are all important? We have the partners, each and every partner contribute things on part of our overall solution and other stuff, and that's where the technology partners are very important. And when you talk about, there are a lot of people ask why IBM COE, why not the other company COE? I don't want to mention here other companies, but why IBM COE? What is the difference it makes? I told you about that. It's a 111 years the company with a lot of technologies, and 25 years ago also, we had a big system built, and those system tested for playing with a Gary Kasparov kind of the world champion, and even now we are doing a lot of things that I'm going to mention, but that's why the why IBM. So IBM built an operating system called AIX, and this has been there for 35 years. This is actually the operating system runs on IBM Power systems. The power system is basically, it's not that the electricity we are talking about here. The scalable power technology, which I said, the power parallel technology, that also built using the power processor. The processor is basically a RISC-based architecture, and it has been there for last 35 plus years since we found the AIX operating system. So this operating system has been very important for industries. Many banks and manufacturing company and oil and industry and many other the companies who needs 24/7 365 days operational things for the system, like a kind of with the high availability and disaster recovery, they all go for AIX. Even in India, I would say many banks, including Reserve Bank, I don't need to mention that, important banks in India do have this AIX on power, and it has been supporting them for highly available kind of system, so which has got a lot of special features. And certainly if you guys need more information, I'm ready to share that also on that. Even Professor Agyadas is trying to work with our team to put together a curriculum around this AIX operating system too. So just wanted to mention that upfront on that. But there are a lot of other things also going on with the AIX operating system that I will mention you in my following slides. And we talked about operating system. We talked about 25 years back, the scalable power system, but the future. So you guys know about the nanometer and the competition around the world and all the stuff. So right now, IBM Power 10 system, base system Power 10 processor based out of the 7 nanometer. It's a kind of a smaller chip. The gap between the the silicons inside the chip, and now IBM invented a technology where we could build 2 nanometer chip. Think about it. The chip size is going to be very small, with a nanometer going to go 2 nanometer, and this is the first time IBM put together something from our Albany lab. Albany is a New York State capital, and we have a very good lab there. You guys can take a look at take a Google up on that. Even some of the people are doing courses there close to the lab called RPI Institute, Rensselaer Polytechnic Institute. That's one of the oldest institute in New York State, and with the funding from state government, as well as IBM. We we built this lab, and we also, developed this technology in last 2 to 3 years time frame. And there are a lot of other things going on in that lab, in addition to, the big blues, the world first 2 nanometer chip technology. And people can, we designed this technology. People can pay a royalty and, take the technology and go and build the chip. And that's how we rock, even after 111th year, we are actually, doing from the chip to the solution, to the customer. When I say customers, it could be university students too, because the students are the one, today's students, tomorrow, they are going to be developers for many companies, whom we are collaborating with. So that's very important too. So take a look at it. This is a very important moment, which I am sharing right now. And this 2 nanometer the chip technology going to unlock the potential of many technologies like hybrid cloud, artificial intelligence, and Internet of Things. And also, when I combine, this AI and IoT, it's called AIoT. So many areas, it's getting advanced. And take a look at it. And and if you want to know further information, we are here to help you out, to know more about it also. For the electronic students, definitely, they'll be interested to know. And we do have a kind of a workshop available for all the students, from zero to chip technology. I mean, you can fabricate the chip, that level, we can take you up. So this is the second one, which I want to mention after AX. And the third one, very important, many people worked with us in 2017 to build a massive supercomputer called Summit in Oak Ridge National Lab, which is part of University of Tennessee. And this is another important moment. Right now, the second largest supercomputer is IBM's. Even now, we launched it in 2017, and now we are at 2022. 5 years again and again. We are we were number one, and now we are number two. But in the US, it is a number one system. I just want to tell you, worldwide, it's a number two system. Because every year, people, do develop, new technology and try to put it. And IBM did develop with the help of a Department of Energy in US and build this massive supercomputer. And this is a very important supercomputer. And Mr. Agyadas also got access to this computer and built some applications too. And this has got like a 2000 node cluster, and with the massive GPU and the CPU, the Power 9 CPU capabilities. And also the Google also using our Power 9 processor for their data center deployment. And they communicated that as part of one of the summit in 2018. These are all the the major the power things, including industries, scientific companies, and universities, all use worldwide, the power based, supercomputers to industry based computer for the superior power. And I definitely need to mention to you about the Open Power Foundation, because I am part of that, leading the academic initiative for the past 7 years. There are a lot of opportunities for people to get into this and develop technologies as part of that. So when I say the Open Power, is basically a foundation established by initially in 2013 and 2014 timeframe by 5 companies: NVIDIA, Mellanox, IBM, Tyan, and hold on, I think, Google. That's one other important company, Google. There are 5 companies, established this partnership, and now the partnership is still going on with all these companies. But there are some companies merged together, NVIDIA and Mellanox right now called NVIDIA, because NVIDIA acquired Mellanox, and they added their networking infrastructure as part of the NVIDIA infrastructure. So with this, you can see all these partners, we have like a 300 plus partners. Universities also participating, like 100 plus universities as part of this the Open Power ecosystem. The foundation we established to create architecture ideas, add new ideas to our power architecture, to the power systems platform, from silicon to the application. we opened up technology, and people like developers and students and researchers and many other collaborators collaborate on our platform, including the Professor Agyadas has been very collaborative on this for the last 4 years from other university where he worked in the past, and now he's working with Alaska. All these things he's also putting together. So it's a foundation. I welcome the BITS also to be part of this foundation and work with us and collaborate with us. And there are a lot of opportunities are there for people to develop skills. Because this is an open source platform. What does it mean? It's all free stuff. If it is free, that doesn't mean that it is not a good product or whatever. But there we want ideas from people. Like basically the people can contribute to it, and then they can basically march towards some kind of innovation onto it, and then create a platform also. So from the silicon to the application, people can create platform, and that's where the Open Power stands right now. And you can take a look at openpower.foundation, where you will get a lot of ideas. And I'm also going to share some of the links later on about how to join and how to discuss in Open Power Foundation and how to collaborate using the IBM Powers technology. And we have a lot of courses also available where you can freely get into it from our YouTube channel and all the stuff. And we talked about 3AX operating system and 2 nanometer the chip technology. And now IBM has been a leader for patent leadership. I hope you guys know about patent. Patent is nothing but coming out with an innovative unique idea which he needs to file it so that you will protect that that idea belongs to you, kind of thing. If you guys want to know more about patent also, I'm ready to share with you in another session freely. There are a lot of patent farming which I arranged in the past 10 to 15 years in IBM, within the IBM club and universities and all. So there are a lot of documents I have, and there are a lot of my employees who file patents, and now they become like a 100th patent or 150th patent also. So IBM as a company has been a leader in filing the patent and getting the patent for the last 28 years to develop some new ideas on top of our infrastructure too. And these are all the important factor for you to get into career and develop something new with operating system, with the nanometer kind of the chip technology, or with the open power stack from silicon to the application, and certainly you can put together an idea and file a patent. And these are the things will help you to grow in your career for sure. And you become a kind of a master inventor, or the solution architect, or operating system kernel architect, like that. Many positions people will lead in the future the IT arena. So there are 4 things I mentioned why COE and how that is connecting to all these technologies. And the 5th one, even now today, all these industries, I said about many industries, 18, but here I'm talking about like a 12 plus industries. And government, banks, telecom, pharma, manufacturing, energy, food processing, commodities, textiles, co-op banks, construction, auto parts, automobile, all these industries work with us to basically develop IT solutions for their companies, for their industries. And that's where it is all. Tens to thousands to millions of transactions happen on IBM platform even today. I talked about 25 years back, there were a lot of systems we built to play with players like Gary Kasparov, and now we are actually building system for making a lot of transactions. These are the important factors which you should know, and also the industries where we collaborate also I mentioned. So these are all the take homes. I just note down this. And then knowledge, professional CDO skills and training and all the stuff we are actually equipped with. There are a lot of academia initiative from IBM and Open Power and from our partners available. Do engage with them and with us, and and get yourself digitalized in the sense digital transformation. IBM leading, in the digital technology also for the world, for nearly 194 countries, and we have offices where we collaborate with, and certainly, we are here to help you out, to develop skills, combining knowledge, skills, value, and purpose. And AI lab. So I have been setting up AI lab worldwide. The recent AI lab which I set up, one in actually University of Oregon, which I am going to walk you through within my limited time. Looks like I started a little late, so I may take some more time. So the AI lab, what does it mean? This is what it is: the open source system for data analytics with accelerator, collaborative technical projects one can do with this, access to IBM academic initiative toolkit, graduate, PhD, and postdoctoral research people can apply for, webinars and technical workshops. So many things we have done in the past. Hundreds of webinars and workshops we have done in year 2019 and 2020 and 2021. And then projects related to make smart cities and smart villages. There are a lot of projects available from silicon to the application. If you want to work on a silicon to develop a chip technology, we have projects. If you want to work on developing some kind of a solution to solve a problem, addressing a problem area, we have areas to work on. We have a lot of programs available. Reach us out. Definitely, the students can collaborate with us. So this is a kind of a small environment where one can set up a center of excellence, and students can do work on that. And just for your understanding purpose, and I just mentioned a couple of servers here and storage, and we have AC922 or IC922. These are all the systems to accelerate the application for you to run it on a system. So take a look at it, and certainly you will get more skills later on. We have a free access also for the people who wanted to get onto the system and collaborate with us on projects. And then I just want to skip this. This is actually the one system, one of the systems configuration like that. We basically put together 2,000 systems to build that world largest supercomputer in 2017, and even now it is still the second largest supercomputer in the world. And then storage server. Yeah, definitely there are two things in compute. I mean, in IT, very important. One is computing. For computing, we need computers. I mean, to calculate. That is actually CPU and GPU, and we need data to store, and that's where very important these days. The data and AI. Wherever the data is there, the compute has to be there, so that whatever data comes in, we just evaluate and make the data more powerful, and we enable the data to make it more useful also. So that also I'm going to walk through later on. Is using AIoT kind of the work groups and work ideas. And Agyat has already mentioned about some of the stacks, what he has been doing. Similar to that, we have a AI lab software components, Power AI Vision, Power AI Enterprise, to accelerate your application with our partners Auto AI, IBM, PyTorch, Cafe, all these open source based components. And we have the operating system from our another company called Red Hat. We bought the company 2 years back, and also Python and Kubernetes platform for cloud. All these things available on a kind of a package format, and one can use it immediately after this training also, if possible. We can selectively give access to these people on that too. And then I want to walk you through how the university use cases and scenarios for AI lab. Immediately I would say that the students request for compute resources, basic MLDL exercises. Hey, I'm talking about a server technology, not a laptop. I know most of the people run AI program in the laptop only, but in the server, it makes a difference. It's like driving a Benz car, whatever we have, the server, and that's where the big difference. So for students access, we have a special scenario where students can get into that, to do basic MLDL exercises. And then final year students, they definitely need more access time. So, and also project based access, AI projects. For that also, we have use case many use cases, built on that. And then the final year students wanted to do some kind of a, projects, final year projects. For them also, we have more storage available for them to store the data so that they can do the compute easily. And with, our Power AI kind of, offerings. And then the use case 4 is lecturers. Definitely, we want to give access to the lecturers, who can use this, to teach, many students in the universities too. And, which kind of colleges can have this kind of labs within their campus and, provide the kind of a Benz, the Mercedes Benz kind of experience to the students, so that, they get, the hardcore technology experience, right there in the college. They did not have to come and, work as an employee and, get their experience. And that's a plan, which we put together long back, and, we have been communicating this to many colleges worldwide. And then it's a 2 years development program with the AI lab and Center of Excellence. One can get all these features. I'm going to walk you through quickly, and there are a lot of offerings along with that. Some of them is software offerings, and then we have a scheduler also, our own IBM scheduler available to schedule the jobs whatever you are issuing as part of the AI lab. And the stack whatever I mentioned previously, this is a stack where people can collaborate on that, and most of the stack components are open source, and certainly people can download it and start working on it too. And then the one thing I want to mention here is, what is the advantage you get? Either you join as an Open Power Foundation member, or you collaborate with us on our Open Power platform or IBM academic platform, or overall the university engagement with setting up a Center of Excellence at your institute. Talent and skills, differently, the talent and skills will be developed after attending this workshop. Also, people would develop some skills, and probably they can nurture into it, and then create more skills, develop more skills. And then publication and mindshare, this is very important. People, when you look at your resume, you got to have GitHub kind of GitHub or GitLab kind of pointers where you have to mention about the projects you have been working on, and the publications you have been doing with the LinkedIn or a Twitter kind of accounts, and then creating mindshare for the people. And those are the things very important, and we provide that kind of mentoring, and our weekly and regular workshops will help you out to develop those skills too. And then intellectual property, I did spend definitely 2 to 3 minutes on that. Intellectual property is one of them is patent, and very important, and also prototyping, demos, curriculum, student projects, and thesis. All these things, we have ways to help you out, reach us out. It's not just me. I've been telling, we have hundreds of people are collaborating on our Open Power platform, and there are a lot of opportunities for you to collaborate. And then opportunities. So startups, if somebody wants a seed revenue, people also can get some guidance, and there are a lot of companies do work with us, and put together a kind of a compelling report about the company and the future technology and all this stuff, and try to get funding also for their startup and other stuff. So these are all the 4 things one can do with our Open Power kind of a platform with IBM Academic Initiative. So the special courses what we offer here is, many courses are there, which definitely you can knock the door with Open Power and with the IBM Academic Initiative. There are things which are freely available too. People can take up, and enjoy, with the technology what we have. And then I said before, we have Silicon to the Application kind of a program. That's where I'm coming here right now. Processor core enablement and partnership. We have open source our the ISA infrastructure called instruction set architecture. That is the one needed for, is a kind of a standard needed for developing an RTL to develop a processor or a system on a chip. System on a chip. And all these things you can do it with this Open Power processor enablement partnership. So take a look at it and let me know if you guys interested to learn about Silicon to the application development. And then, as I said before, these are all the core partners. One of them is OnStute, who are our educational partners who provide a lot of open power-based courses, power-based courses on the infrastructure, on their infrastructure. And there are a lot of already, the courses like the machine learning courses and, the multi-core architecture course, which we offer to one of the universities in India, and also the Open Capi course, which is another accelerator that is also available through this OnStute platform. And we have plans to develop more courses in the upcoming months. And please do take a look at the OnStute platform. And it's a great platform for you to get engaged quickly and get certified also. We have done, as part of the partnership, thousands of people get certified on this OnStute platform. And that's a very important feature for you to take a look. It's a freely available right now. You don't need to pay anything. Start today only. Start looking at the OnStute platform and see how you can get certified and accelerated your career. And University of Oregon, I can't forget to mention that they are one of the key collaborators for Power worldwide, and they have lots of power-based systems like enterprise AI servers to desktop servers. They have nearly 10 plus servers available for students to collaborate with us for hackathon, for workshop, for webinar, for project thesis, and several other things. These servers are all cost around more than $1 million, but it is available for you to use and develop a new technology. And also the University of Oregon do have kind of a software called E4S, which they are building it for a future supercomputer. And E4S basically gives you a kind of a 80 plus the softwares, open source softwares, which you can do everything. And that's an important feature of E4S. Take a look at it. Take a look at the tau.uoregon.edu website, where you will get some ideas about tau as well as E4S. And that's a great opportunity for you to start looking at all these kind of tools and libraries for you to collaborate on the stack, the supercomputing stack as well as the industry-based stack. And then Ohio State University also built a software called XScale solution. It's basically kind of a solution they built using the MPI, one of the MPI standards called EMEA Pitch 2, and it is also available in University of Oregon for you to try out. It's basically kind of that one can do one node system very well, one server or one laptop. But here we are talking about 2,000 nodes, where how do you run a deep learning application, a distributed deep learning application? That's where the exascale solutions will play a big role here. You cannot just run your AI requirement on a 2,000 node cluster, because when you run it on a 2,000 node cluster, your training time will reduce very tremendous. I mean, in a big way, and you get it done in seconds. And that's where the XScale solution makes a big difference here. And take a look at it, and certainly we'll help you out to learn more about it too. And then before I conclude this session, I'm going to walk you through the University of Oregon system and see what is available for you to use it. You can request for it. Some good students. Certainly, I'll be opening up the access to the systems too. And also, we set up the worldwide, IBM Center of Excellence at the University of Oregon, and also it's an open power hub where you get to see the system access and all the stuff. So take a look at it right now quickly. Let me walk you through. This is the system what we have in University of Oregon, and partnering with some industries like Werner Transportation Company. And this is the system we have. Like one can do with the system many things. See, the look at the infrastructure what we have here. We have storage file system. We have Red Hat. We have
Ganesan, are you sharing anything other than the PowerPoint?
Yes.
Okay, so we can see only that PowerPoint thank you slide, by the way.
Oh, hold on. you should be able to see my screen now.
Yes,
Right?
yes, sir. Now it's fine.
Yeah, looks like previous PPT I shared, and I have to share again the other PPT. Okay, thanks for that pointer. So University of Oregon, the systems available, whatever I'm going to walk you through, and we have a 3 enterprise server system. These systems right now predominantly run by a lot of banks and manufacturing companies worldwide, and it's available. And we have DB2, kind of a database from IBM. DB2 has been there for last 45 years in IBM, with the AX, 35 years, and the Red Hat and the AX, all these things available for students to use it. And it's a these 3 systems cost around $1 million. Just want to tell you the number. $1 million is nothing but, as per Indian currency with the dollar rate, is actually 8 crores. So move on. And then this is the configuration of the enterprise Oregon system. And then we have projects also, people work on it, and there are a lot of projects which I'm going to go through that. AI servers with the University of Oregon, the task list, there are a lot of projects where we are working with the industries and university partners, and these are all the project ideas, developing use cases and all this stuff. What Professor Agya mentioned many during his talk about the machine learning with PyTorch and all the stuff. All those environment is available here. If you have a good project to work on, you can make a request to me directly, and certainly we will give access. There are hundreds of people right now using access and developing good technology on top of our platform. And you see that these are all the the project ideas which we have been working with the universities as well as industries to form, and then we will collaborate on with them and develop these ideas. Many use cases are there. I'm going to share with you all. So yeah, we have AC922 also available in University of Oregon, where people can go and try do some activities. You see here there are 4 systems available as part of University of Oregon systems, available for students and researchers to get onto the system. And then we have IC922 system with OpenCAPI accelerator also available. And we have Raptor systems, like a desktop kind of model, also available for students to work on. It is, I'm not here. This is all for people to collaborate. That's where you get some a good career as part of this too. And then we have system where one can develop a chip technology too, and for developing a physical layout, as well as developing a FPGA. I mean, synthesizing the the IP core into the FPGA. We have infrastructure available for you to do that. Why not? There are a lot of opportunities you have right now. It's all the eye opener. And let me see how many people wanted to come out with a plan and other stuff. There is definitely a need. You got to have some good plan. You cannot just request for access just like that. Sir, I want to run a program which is in the GitHub or whatever. You got to practice something and then come to the server environment to get trained more on how the server works and how the GPUs you can use, more than one GPU or more than one node. I talked about even 2000 node access also possible to get. So these are the things I have as part of the presentation. And certainly you can all reach me out. I'm openly giving my email ID here. You can all reach me out, and if you want to get access, or if you want to participate in any of the technology, certainly we are here to help you out, from silicon to the application, all together with all our under partners, including Professor Agyadas from Institute, as well as from University of Alaska. With this, let me close here, and I'm actually open for questions right now.
Thank you, sir. Very wonderful session. Your speech was so motivating and inspiring. And obviously, students will ask questions they have some many questions about open power AI. So students can ask questions, or participants can ask questions by raising hands and writing into the chat box. So please.
Yeah, it is also good for the faculties to not just faculty. I also encourage and motivate faculties to be part of these collaborations too, like how Professor Agyadas has been collaborating, as an example. Like that, faculties also can get engaged, and you too have a career here, faculties, right? That's what. So
Yes,
certainly,
yes, Ganeshan. Yes,
yeah,
we already have a talk with our PIT management and as well as all the HODs. And I think you had already had a discussion with our EC HOD madam. So we are working on it. Maybe in a recent future, we'll have a good collaboration again with you. Other collaboration. We'll start doing the
Yeah,
program.
sure. And also I just wanted to add a small things after Ganesan's talk. And thanks Ganesan for this wonderful talk, and thanks for opening all these opportunities to BIT, and thanks for collaborating with me. Of course, he's my oldest
Thanks.
collaborator for Untitled. And so one thing for BIT, if you need any type of course or any type of assistance on accessing these open power related things, on the infrastructure training or any type of software training that will run on IBM Power Stack, feel free to contact Institute. We can give you all the training required to the faculty members as well as the students and everyone.
Sure,
Okay,
Dr.
sure. Thank you, sir.
Thank you for this kind of opportunities. Means really we are eagerly waiting for that kind of opportunities, and maybe we had a talk with our management, and surely we'll officially proceed with this. Thanks a lot, Ganeshan and Dr. Das. Okay, ma'am.
thank you.
Please continue. Yeah.
Thank you all.
So if anyone have questions, they may ask. Any participant has any questions? So no questions. So now we will be sharing a token of appreciation now. So please, Sonma, share.
Yes. Yes, sure, ma'am. Yes, thanks, Sir Peter. Sir, this is a very small token of appreciation from our Department of CACIT of BIT and as well as from the behalf of my college. Please accept.
Thank you for a wonderful certificate, and thank you. Thanks a lot.
Thank you, sir.
Yep, and I just want to leave another note here. I just posted the chat in the chat window about how students can join our academic initiative in open power. All the students welcome to see it and know what are all the upcoming programs coming up as part of the open power. And it's all mostly 100%. It is free of cost. Do part of the ecosystem and develop your skills too. That's a very important feature for you to basically develop your career.
Thank you very much, sir.
Students, you can find the link in the chat box. So as sir already said, so you can easily access you can click on the link and you can easily access the open power education. If you have any queries, Ganeshan sir and as well as Dr. Argo sir has shared their email ID and address, so you can communicate with them directly. Yes, ma'am. Over to you.
So it's time for feedback now. So Urpita or Sayoshi madam.
Tanmay sir, please make sure that the form is opening or not.
Okay. Checking. Yes, it's opening.
Thank you so much.
So Siddhant Sharma, do you have any questions? Okay. So thank you all the participants for being with us, and now we are concluding today's session. So all the participants are requested to join tomorrow sharply at 9 a.m. Thank you all, everyone.
Thanks, Dr. Argo. Thanks.